Talk about derivatives of inverse trig functions. We've talked about the derivatives of inverse functions, of like polynomials and just other just equations with x's and y's and powers. But now we can talk about derivatives of inverse sine and cosine and tangent. Now this is arc sine, this is arc cosine, this is arc tangent. Other ways to write this would be sine inverse. This is not sine to the -1, but it's rather sine inverse. And this would be cos inverse. And this would be tan inverse. And the derivatives of these are just rules that you have to remember. I can show you how to develop these rules, but it's probably better if I just show you the rules so you don't get confused. It's something that you have to have memorized. There's always 1 or 2 questions on the AP exam that have to deal with these derivatives, and if you know them, they could be easy answers. If you don't, then that's another one that you could get wrong. So the derivatives of these, for sine, I would say that the derivative is 1 over the square root of 1 minus, now sorry, f of x here. If this was just x, the derivative would be 1 over 1 minus x squared, okay? However, if it is a function, well, then we have to use the chain rule. And the derivative is 1 over the root of 1 minus my function squared times the derivative of my function. That being an application of the chain rule. Okay? Derivative of cosine is very similar to the sine, arc sine, only it's going to be -1 on the top. And on the bottom, we'd have 1 minus. Now, again, if this was an x, it's just cosine of x, we'd have x squared here. But since it is the cosine of a function, we would apply the chain rule, and we'd have the function squared times the derivative of the function, chain rule. And then finally, let's put these up. The derivative of arc tangent, the last one that you need to know, is similar to these as well. It's positive 1 over, and instead of a square root, and instead of a minus, it's 1 plus. Now, once again, if this was an x, just the inverse of tangent or arc tangent, this would be just x squared. Since it is a function, it would be the function squared times the derivative of the function. Okay? And that's it. If we just remember these rules, we're good. Let's do a couple examples like these. Find the derivative of the following. This is arc sine of 2x. I want to take the derivative with respect to x of this. I'd get y prime, or dy dx is equal to. Now, derivative of arc sine is 1 over root 1 minus my function squared times the derivative of my function. There's a 2x there. If we want to simplify it, we have 1 over root 1 minus 4x squared with a 2 up top. Okay? Let's look at arctangent of 3x quantity squared. Maybe I'll make this tan inverse. Well, this is a chain. It's kind of a combination of multiple chains. We have the outside is the function being squared, so the derivative would be 2 times our inside to the first. Then I have to multiply by the derivative of the inside. Well, the derivative of tan inverse is 1 over 1 plus whatever my function is squared times the derivative of my innermost piece, which is 3. That gives me my derivative. Okay? Your homework, you have a bunch of derivatives you need to find. We stick with the arc sines, arc cosines, arc tangents. And they should be easy enough that you guys can do them, so I'm not too concerned. But if you have questions, come in and we can talk about them. Thanks. Actually, let's look at the homework. We have some time. So 41 through 52. I guess they do have an arcsecant in there. You just have to think of arcsecant as being 1 over arc cosine. I believe that's correct. No. Skip that problem. So just do 41 through 43. And then do 45 through 48. 50 is not bad. 51, 52 is not bad. Yeah, let's just do those. I'll do one of the tougher ones for you, like 51, just so you can see it. So on your homework, here's 50 number 1. 50 number 1. Number 51, the derivative of y equals x arc cos. So cos inverse x minus root 1 minus x squared. Let's take the derivative of this. I get y prime equals, it's a product right here, so I need to use the product rule. I'll have f prime g, let's leave this cos inverse, plus g prime, that's negative 1 over root 1 minus x squared times f. And I can take the derivative of this guy using the chain rule. So it would be minus whatever this derivative is, 1/2 1 minus x squared. So the negative 1/2 times negative 2x. Now, this is the derivative. Can I simplify this? I bet I can. Can you leave this as an answer? Sure. Let's see what happens if I simplify it. I got cos inverse x. I get negative x over this. This cancels, the negative cancels. I end up with x over root 1 minus x squared. So since this is a positive and this is it, this plus this is just 0. So the answer is just the inverse cosine of x. And I hope if you check the odds that that's the right answer. All right, good luck.